Hi, my name is Amelia, and I will talk about using evidence-based practice in teaching addition and subtraction. Research findings have shown that 5 to 8% of school-age children are identified as having mathematical disability, and that some of these students have difficulties in both readings and mathematics instruction. Unfortunately, research on understanding what constitutes a mathematics disability and how it affects learning has lagged behind similar work in the area for reading disabilities. For example, compared to the research based in the early reading difficulties, less attention has been paid to early difficulties in mathematics and to identify mathematics disability. Mathematics difficulties appear to be persistent and evident across elementary and secondary levels and into adulthood. With that in mind, early intervention is needed to prevent the students from lagging even further. For students with learning disabilities, mathematics is one of the most difficult subjects to deal with. Studies suggest that students with learning disability enrolled in 12th grade perform at 5th grade level in math, and students with the learning disabilities aged 9 to 14 show minimal improvement in computation annually. Students with learning disability usually possess deficits such as memory deficit, difficulty attending to tasks, and passive approach to complete a task. With that in mind, they tend to face problems in the classroom. Given the challenges that students face, it is important for teachers of students with learning disability to deliver math instruction using evidence-based approach, as these practices are most likely to improve students' achievement. Evidence-based practice works for children with learning disability as EBP is able to address their unique learning needs. Besides that, EBP are flexible tools that can be combined with teachers' experience to help improving students' outcome. Here is the process of implementing EBP in the special education. First, systematically identify and disseminate evidence-based practice for students with disabilities. Select the EBP according to students' learning needs and instructional goals. Teachers' experience, strength, and educational environment must be taken into account too. If necessary, adapt non-essential elements into the practice to meet the learning needs and instructional goals of students, the teacher's strength and experience and educational environment. Infuse the implementation of EBP with effective teaching technique. Monitor individual student performance frequently and regularly. In this presentation, I will focus on developing children's addition and subtraction skill using evidence-based practice and explicit instruction. Study regarding effectiveness of explicit instruction in mathematics lesson began around 30 years ago. This approach includes an instructional sequence that begins with an advanced organizer, followed by teacher demonstration, guided practice, independent practice, and maintenance check. Important teaching practice included in the explicit teaching are gradual presentation of new information, use of examples and non-examples, structured and continuous practice, high level of questioning, feedback, and result monitoring. According to a study by Hudson and Miller, EBP can be used to develop conceptual knowledge, which in turn helps students to understand addition and subtraction. In this setting, students' conceptual knowledge improves when they realize the connection between addition and subtraction. An application for this concept can be explained by using 10 blocks as manipulative to support concrete students' understanding. For example, if the students take 6 blocks from the stack of 10 blocks, he or she needs to add 6 blocks to get back to the original amount. For example, 10 minus 6 is 4, and 4 plus 6 is 10. Here is the example on how to use EBP to teach conceptual knowledge. Prepare the materials, such as 10 pieces of Unifix cube and 10 frame. Review with the students what a 10 frame is and how we can combine two numbers that add up to 10. Give some examples of number combination that add up to 10, such as 3 plus 7, 4 plus 6, 5 plus 5. The teacher could say, if I place 2 cubes on the 10 frame, how many more should we add in order to have 10? Each time students try a number combination, ask them to list the number sentences. Moving on, start with a 10 Unifix cube on the 10 frame. Remove certain number of the cube from the 10 frame. For example, the teacher removed 4 cubes from the frame. Ask the students to count how many cubes left and write the number sentences, such as 10 minus 4 equal to 6. Ask students how many cubes we have to add to get back to the original amount, and write the number sentence, such as 6 plus 4 is 10. After the students gain more experience, they could complete a worksheet about addition and subtraction inverse relationship. Prepare the materials, such as 10 pieces of Unifix cube and 10 frame. Conceptual knowledge is also built when students are able to relate new concepts to the concepts previously learned. For example, students might have understood the concepts of more than and less than in terms of quantity and later link this concept with addition and subtraction. For example, initially the students understand that 4 is more than 1 and 1 is less than 4. However, by linking this concept to addition and subtraction, students will be able to understand 4 is 3 more than 1, or 1 plus 3 is 4, and 1 is 3 less than 4, or 4 minus 3 is 1. Hudson and Miller emphasize the importance of manipulatives and representation in helping students to develop conceptual knowledge. A systematic way to integrate the use of manipulative devices and pictorial representations into explicit instruction is through CRA, or concrete representation and abstract teaching sequence. The CRA sequence begins with instruction at the concrete level. This involves the use of manipulative devices to represent the concept being taught. First, the teacher uses the manipulatives to illustrate the concept and solve related problems. Then, students are given chance to use the devices during guided and independent practice. When students have mastered the content using the manipulative devices, instruction progresses to the representational level. Representational instruction involves the use of pictures of objects or tallies. Again, the pictures or tallies are used in both demonstration and guided practice. Once mastery is achieved at the representational level, instruction proceeds to the abstract level. In this level, students have to solve problems without using manipulative devices, pictures, or tallies. Studies have noticed that 3 concrete lessons using manipulative devices and 3 representational lessons using pictures and tallies, with each lesson consisting of 20 problems, is sufficient to understand the concept being taught. The CRA instructional approach has been used successfully to help students with learning disability master concepts related to a variety of mathematics standards. Specifically, it has been used to teach algebra skills, basic math facts, fractions, multiplications, and place value. Regardless of the specific math content being taught, several instructional guidelines can be gleaned from the literature related to the development of conceptual knowledge. These guidelines are intended to enhance teacher effectiveness and efficiency. Here are different types of manipulatives that teachers can use to teach addition and subtraction. Base 10 blocks, buck counter, link and learn, snap cubes, and bear family counter. When the goal of math instruction is to help students understand the meaning associated with the process they are learning or the concept being taught, it is important to provide various modes of representation. Use of the CRA sequence ensures the concepts are taught with both 3D and 2D representation. It is also helpful to vary the manipulative devices and pictures used. Thus, students learn that addition is not only associated with certain manipulatives. When selecting mode of representation, it is important to consider characteristics of the students, such as their fine motor ability. Students that have difficulty with fine motor skill may need larger object or virtual object. These time students may need additional white space on worksheets or separate sheets of paper to draw pictures or tallies during representational lesson. An important point to remember: although there is a high chance that EPB is effective, it does not mean that every student will respond positively. With that in mind, educators have to conduct formative assessment to determine the effectiveness of the strategy for each student. If students' outcomes do not improve adequately, the teacher should be prepared to choose a different strategy to better cater to the learner's need. This is the end of the presentation. I hope the strategies and guidelines provided in this presentation will help your students to develop mathematics skills.